Math lesson number 32. Equations involving radicals. Solve the following equations. Number 1. Square root of x plus 3 is equal to 6. So first, we need to square both sides to remove the radical sign. So this one squared and then 6 squared also. Now, the radical sign is removed. The result is x plus 3 is equal to 36. Transfer 3 to the other side, it will become negative 3. So that will be 36 minus 3 is 33. So x is equal to 33. Now, for checking if 33 is correct, we need to substitute 33 to x. So we have 33 plus 3 is equal to 6. Now, 33 plus 3 is 36. Square root of 36 is 6, which is true. Therefore, 33 is correct. Number 2. Square root of x plus 3x is equal to 8. Again, square both sides to remove the radical sign. So, squaring, and then the radical sign is removed. X plus 3x is equal to 8 squared is 64. Now, x plus 3x is 4x, which is equal to 64. Now, dividing both sides by 4, x is equal to 64 over 4, which is 16. Now, let's check if 16 is correct. Substituting 16 plus 3 times 16 is equal to 8. 16 plus 3 times 16 is 64. Square root of 64 is 8, which is true. Therefore, 16 is correct. Number 3, x square root of 3 is equal to 9. Now again, squaring both sides, we have x squared is x squared, square root of 3, quantity squared is 3, and then 9 squared is 81. Now, x squared is equal to 81 over 3, which is 27. Now, to remove this squared, we need to do square root. So, square root of x squared is equal to square root of 27. Now, square root of 27, there is a perfect square factor, which is 9. So, square root of 27 is square root of 9 times square root of 3. Square root of 9 is 3. So that will be 3 square root of 3. So square root of x squared is x. The squared is removed. So the final answer is x is equal to 3 square root of 3. Number 4, square root of 5x is equal to square root of 3x plus 10. So square both sides to remove the radical sign. That's 5x, and then this one is 3x plus 10. Now we can combine similar terms, 5x and 3x. That will be 5x minus 3x. Why minus 3x? Because 3x must be transferred to the other side. So it will become negative. Now 10 is left. 5x minus 3x is 2x, and then 10 is 10. Now divide both sides by 2. So 10 over 2 is equal to 5. So x is equal to 5. Number 5, square root of 5 plus x minus the square root of x is equal to 3. Now, first, we need to transfer square root of x to the other side. So this is one method only. You can actually use another method or other method. So square both sides, square root of 5 plus x squared, and then square root of x plus 3 squared. Now squaring this will remove the radical sign, that will be 5 plus x. And then this one we will use perfect square trinomial or squaring a binomial. That will be square root of x squared, that's the first term, and then 2 times the product of the two terms, square root of x times square root of 3, and then squaring the last term, 3 squared. The last term is 3, so 3 squared. Now simplifying, we have 5 plus x is equal to square root of x squared is x. 2 times 3 is 6, and then square root of x. 3 squared is 9. Now, changing the position, we have this one is this, and then this one is this. Then after that, x and x are cancelled. So, what is left is 6 square root of x on this side, and then 5 on the other side, and then transferring 9 to the other side, it will become negative 9. So from positive to negative. No, 5 minus 9 is negative 4. So in order to get x, we need to isolate square root of x first. So that will be dividing both sides by 6. As a result, you have negative 4 over 6 square root of x. Now to remove the radical sign, we need to square both sides. That will be square root of x squared, and then negative 2/3, that's the simplified form of this, squared also. So x, the radical sign is removed, is equal to negative 2 squared is 4, 3 squared is 9. So this is the value of x. But let's check if this is correct. Now there are two cases, of course. If only the principal root is considered, no negative roots. Let's substitute 4 over 9 to x there. So that will be 5 plus 4 over 9, because that's 5 plus x. And then square root of 4 over 9. Now, this one, that's 9 times 5, 45, plus 4, 49, over 9. So that's how we add whole number and fraction. And then square root of 4 over 9, which is equal to 3. Now, square root of 49 over 9 is square root of 49, 7. Square root of 9, 3. Square root of 4 over 9 is square root of 4, 2. And then square root of 9, 3. Again, we will only consider principal root or the positive root. So 7 minus 2, the denominator is the same, which is 3. So 7 minus 2 is 5 over 3, which is equal to 3. Now, of course, 5/3 is not equal to 3. Therefore, x is equal to 4 over 9 is not the solution. Hence, the radical equation has no solution. So if we are only considering principal root. Now let's have case number 2. Others will consider negative root. So plug in, same thing, 5 plus 4 over 9, and then square root of 4 over 9 from here. Now, as you can see, since square root has two answers or two roots, the positive and the negative, so we will consider the negative in the second term. So square root of 49 over 9 is 7 over 3 minus, here we will consider the negative root. So square root of 4 over 9 is negative 2/3. Square root of 4 is 2. Square root of 9 is 3. And then the negative, because the negative root is allowed here in case 2. So 7 minus negative 2 is 9. 3 is 3. So 9 divided by 3 is 3. So x is equal to 4 over 9 is one of the solutions if the negative root is considered. But of course, normally, usually, and most of the time, only the principal root is considered. Let's have number 6. X is equal to square root of 5x minus 6. So square both sides, x squared, and then square root of 5x minus 6 squared. That is x squared. And then this one, the radical sign is removed. X squared minus 5x plus 6. So 5x will be transferred to the other side. It will become negative 5x. Negative 6 will become positive 6. So which is equal to 0. So no one is left. Now, how are we going to find the value of x here? We will first factor this quadratic trinomial. So, factors of x squared are x, and factors of 6 are 2 and 3. So that's the right combination to get 5x, because 2 plus 3 is 5. Then we will use negative minus minus because the middle term is minus or negative. So if you're going to check if this is correct, x times x is x squared. Negative 2x, that came from negative 2 times x. And then negative 3 times x, negative 3x. After adding, you have negative 5x. Then negative 2 times negative 3 is 6. So this is the right factored form of this. Now, since this one is multiplied by this and the result is 0, meaning to say one of these two expressions is 0. So let's try if this is 0. Because if this is 0, the whole thing is 0. If this is 0, the whole thing is also 0. So let's try first this first expression. X minus 2 is equal to 0. Therefore, x is equal to 2. So transfer negative 2 to the other side. So x is equal to 2. X minus 3 is equal to 0. So transferring negative 3 to the other side, it will become x is equal to 3. So you have now the two values of x. Why two values? Because our radical equation turns out to be, or turn to, or again, our radical equation is turned to quadratic equation, x squared minus 5x plus 6, which is equal to 0. So from radical equation to quadratic equation. So again, the values of x are x is equal to 2 and x is equal to 3. Now, let's check if this is correct or if the values of x are correct. So for x is equal to 2, we have 2, substituting 2 to x, is equal to square root of 5 times 2 minus 6. Now 5 times 2 is 10. 10 minus 6 is 4. Square root of 4 is 2. So that's true. For x is equal to 3, 3 is equal to 5 times, square root of 5 times 3 minus 6. 5 times 3 is 15 minus 6 is 9. Square root of 9 is 3, which is also true. Therefore, x is equal to 2 and x is equal to 3 are correct. Number 7, x plus 3 is equal to square root of 3x plus 13. So again, square both sides. X plus 3 squared and then this one squared. Now, this is square of binomial x squared, and then the last term 3 squared, which is 9, and then the product, twice the product of the two terms, x and 3. 3 times x is 3, and then twice of that is 6x. So this will be the expansion of x plus 3 squared. Then 3x plus 13, the radical sign is removed after squaring. Now combine similar terms. X squared has no partner, but 6x minus 3x is 3x. 9 Minus 13 is negative 4. Why minus 13? Because we need to transfer 13 to the other side. So it will become negative. Same thing with 3x. So it will become negative 3x. So 6x minus 3x is 3x. No one is left. So is equal to 0 to the right side, or of the right side. Now, we need to factor this quadratic trinomial, and that will be x minus 1 times x plus 4. So again, in factoring, we need to consider the factors of the first term, x squared, that will be x times x, and then 4, that will be 1 times 4. This is negative, so this is minus and plus. So this is the right combination to get the middle term 3x. Now again, x minus 1 is equal to 0. Therefore, x is equal to 1. X plus 4 is equal to 0. Therefore, x is equal to negative 4. Now for checking, we have for x is equal to 1, that will be 1 plus 3 came from x plus 3 is equal to square root of 3 times 1 plus 13. So 3 times 1 plus 13 is 16. 1 plus 3 is 4. So square root of 16 is 4 is true. Therefore, x equals 1 is correct. Now, for x is equal to negative 4, we have negative 4 plus 3 is equal to square root of 3 times negative 4 plus 13. And negative 4 plus 3 is negative 1. 3 times negative 4 plus 13 is 1. So negative 1 is equal to square root of 1 is false if we are considering principal root only. Now, negative 1 is equal to square root of 1 is true if negative root is also considered. So it depends on the problem. Number 8. Fourth root of x is equal to 2 minus square root of x. So first, let's try squaring both sides. So fourth root of x squared is equal to 2 minus square root of x quantity squared. Now, this one, fourth root of x squared is square root of x. Okay, again, fourth root of x squared is square root of x. Now, this one we will use square of binomial, 2 squared, and then twice the product of the first and the last term, or the second term. 2 times 2 times the square root of x, and then square the last term, square root of x squared. As a result, we have square root of x for the left side, and then for the right side, we have 4 minus 4 square root of x plus x. Now, combining similar terms, this one will be transferred to the other side. That's square root of x plus 4 square root of x, which is equal to 4 plus x. Now, this one is 5 square root of x, and then this one is this. Now, squaring both sides to remove the radical sign, we have 5 squared is 25, square root of x squared is x. Squaring this, again, square of binomial, 4 squared is 16. 2 times 4 times x is 8x. Then x squared is x squared. Now, combine similar terms, transfer 25 to the other side, 25x to the other side, so that will be 0 is equal to 16 plus 8x plus x squared minus 25x. As a result, we have 0 is equal to x squared minus 17x plus 16. So 17x came from, negative 17x came from 8x minus 25x. So change the position, this one, and then factor the quadratic trinomial. This one is x minus 16 times x minus 1. which is equal to 0. So again, factors of x squared is x times x. Factors of 16 that will satisfy the middle term negative 17x is negative 16 and negative 1. Now equate this to 0. X minus 16 is 0. X equals 16. X minus 1 is 0. X equals 1. So those are the values of x, 16 and 1. Now for checking, considering only the principal root or the positive root, we have for x equals 1, that's fourth root of 1 is equal to 2 minus the square root of 1. So 1 is equal to 2 minus 1 is true. So x equals 1 is correct. Now for x is equal to 16, fourth root of 16 is equal to 2 minus square root of 16. So that will be 2 is equal to 2 minus 4, which is false because 2 minus 4 is negative 2. Now this x is equal to 16 is called the extraneous root. What is an extraneous root? So it is a root or a solution to an equation that seems to be right. So x equals 16 seems to be right. But upon checking, upon substituting 16 to x, it turns out to be wrong or not valid. Just like this one. So 2 is equal to 2 minus 4 is false. So we call that x equals 16 as the extraneous root.